Let's take a look at how the diploma might ask questions about radical transformations. So the graph of y equals square root of x is transformed into the following graph, and below are possible transformations. So in our transformations, we've got two reference numbers that are horizontal stretches, two that are reflections in the x or y axis, and then four that refer to the horizontal translations. And then the question asks, the transformations from the list above that describe the changes to the graph of y equals square root of x are, and we've got three choices. So we need to figure out which ones of these reference numbers are actually true. So let's start with a horizontal stretch. We've got two options. There's by a factor of 1/2 and by a factor of 2. Looking at our equation, we can see that the b value is 1/2. So we can see where someone might pick that. But remember, it's actually the reciprocal. So therefore, it's 2. And our first answer is 2. Okay, next up, we have a reflection. So our two choices are either in the x-axis or the y-axis. Well, this means that it's going to be shifted or reflected horizontally, which means that's going to be over our y-axis. So there we go. We know it's 4. And then finally, we're looking for the horizontal translation. Now this is where they're going to really get you. This has not been factored out yet. So we need to actually rewrite this as y equals square root, and that negative 1/2 is factored out. Now that leaves us with x, and then negative 4 divided by negative 1/2 is plus 8. Okay, so now we can actually read off what this would be. Now, they're going to get you again here. This is actually a minus 8. Now, minus 8 means it's going left then. So we go and look. 8 left. Yep, there we go. 2, 4, 7.
Here, our next example. A company estimates its product to production using the function where C represents the cost in dollars to produce n items. So A, describe the transformations represented by this function as compared to C equals square root of n. Okay, so we're looking here. We've got an A value of 20, so that's our vertical stretch. And then I have a vertical translation of 1,000. That's it. B, interpret the domain and range in this context, meaning the context of us producing items. Now, if I just look at the regular domain, it's going to be affected by the square root of n. Well, we can't square root a negative number, so therefore n must be greater than or equal to 0. However, the context is the key word here. If I'm producing items, I can't produce 1.23 of an item. So therefore, I actually need it so that n is a whole number. So it has to be in the group of whole numbers. Now the thing about that though is that's actually includes this restriction already, because whole numbers don't include the negatives. So all I need to write is n such that n is a whole number. Now for our range, we're going to look at the smallest value. And we'll just label this, so that's a d value. So I'm actually going to substitute in 0. So 20 times square root of 0. Now this is function notation, plus 1,000. I'm going to write this on the other side. So C of 0. Well, that means C of 0 is actually 1,000. Now what does that mean? Well, that means if I produce no items, I still have to pay $1,000. That's my initial cost just for being in this deal of making these items. Okay, finally, C, what will the expected cost be if we produce 12,000 items? So using our notation, function notation, so C of 12,000 is equal to 20 square root 12,000 plus 1,000. I would put this into my calculator all at once. You're going to get $10,000 and 954. That's it. Okay, our final example. For each graph, write the equation of a radical function in our function notation form. Or sorry, it's not function notation actually. So just a regular form we're used to. My first instinct on here is actually to compare it to the parent function. So that means our y equals square root of x. So I'm going to go and graph that. So 0, 0, 1, 1, and 4, 2. And I'm going to actually compare how these 3 points compare to these 3 points that I'm actually given. I didn't plot the fourth one because it would be somewhere out here. So let's go and compare the origin first. So this is our origin. This was that point before. And we can easily find what the vertical translations and horizontal translation was from there. So vertically, this has been 1, 2, 3, 4 up. And then it's been 1, 2, 3 over to the left, which is a subtraction. Now the reason I know without doing any other work that it's been translated 4 up and 3 to the left is that when I apply my stretches, they happen first, but 0 times anything is still 0. So therefore my vertical translations must be from this origin to here. They have to be from here to here. My vertical stretches have not affected that point, or either stretch hasn't affected that point. Alright, so then we actually do have to go and try to find these vertical stretches if they're there. So I'm going to compare on my original, my origin point to the next point, and that's a horizontal distance of 1. And if I actually look, this is also from my first point to my second point is also a vertical distance of 1. So therefore, 1 divided by 1, just comparing them, yeah, I've got a vertical stretch of 1. Now, maybe this isn't true. We could double check. So then let's go to the second point compared to my third point that I know. That's also a vertical distance of 1. And if I look on my new graph, yeah, it's also a vertical distance of 1. So it's been confirmed. Finally, let's look at the horizontal stretch. So I'm comparing again my origin to my first point, horizontal distance of 1. And then if I go to my new graph, so from what was my origin to my first point, yeah, also 1. Let's just double check though. Let's go from the second point to the third. It is in fact 3. On my original, from my second point to my third point, it's also 3. So if it wasn't the same, 3 divided by 3 is 1. We've got a horizontal stretch of 1. Now there is a reflection here. It's a reflection in the x-axis, so we don't want to forget about that. So that means my a value is going to become negative. So now I need to actually write this out then. So y equals, now we got a vertical stretch of 1, so it's going to be a subtraction. We don't write the 1. Square root. Now our b value in this case is also 1. So I'm not going to write anything there. And then I have my x minus negative 3, so that's going to become plus 3. And then my vertical translation of plus 4. All right, let's move on to the last graph. So I'm going to again graph the parent function, so 0, 0, 1, 1, and then 4, 2. And we're just going to do some comparing of the two graphs. So let's look at the origins. It's the easiest place to start. So it looks like I've been shifted over 5 to the right. So that's a horizontal translation of 5 right. And that is going to be a positive 5 then. So I'll make a little note to myself, that's a plus 5. And then it looks like it's been shifted down 1. So that's going to be a vertical translation of minus 1 or 1 down. Next, the tougher part, let's start looking at the vertical stretches. So from my first point to my second point, so from my origin to my second point is a vertical distance of 1 on my original. Now if I look at my new graph, or my transformed graph, from my first point to my second point, it's actually 2. So far it looks like I'm going to go 2 divided by 1, 2 being my new graph, transformed graph, divided by the original. But let's just double check, just in case maybe something else is happening. Here, maybe a horizontal stretch instead. So we'll compare on the original, the second point to the third point. That's also a distance of 1. And then if I go to my new graph, my second point to my third point is, in fact, a vertical distance of 2. So yeah, this actually holds up for both situations, so therefore it must be 2. Now my last thing is my horizontal stretch. So again, comparing my origin to the second point, distance of 1. And then on my transformed graph, that origin to the second point is also 1. So we're looking at 1 divided by 1. So again, our transformed graph divided by our original is 1. We should double check though. So let's look at our second point on our original compared to our third point. So that's a horizontal distance of 3. And then let's look on a transformed graph. Our second point to our third point is also a horizontal distance of 3. So yeah, horizontal stretch of 1. There is also a reflection on the y-axis, which means I'm going to have a negative b value. So I have all the information I need now. So pulling this off, I'm going to get my a value is 2. I still have that root. Now I've got a reflection in the b value, so minus. Now this is where some people will get caught. They'll start writing x here. Because we have a -1, we don't write the 1, but there's actually a brackets here. So then to apply our h value, and we've got a horizontal translation of +5, so minus +5 is -5. And then finally we've got to apply our vertical translation of -1.